Welcome to the World of Replication for the next hour. My name is Seppo Jaakkola. I represent a company called Codership. And we're developing a Galera Replication system, which is a synchronous multi-master clustering solution for any database. I think the title for this presentation, I guess it mentioned MySQL, but we are generic and we can support whatever database engine, so it's not only for MySQL. Well, we only have MySQL implementation at the moment, but we are reaching out for our other databases as well. And the thing to maybe emphasize in the beginning is that it is a true multi-master, so you can have connections to each of the database nodes, and you can update any nodes. The cluster will take care of the possible conflicts and sort out the conflicts for you. So they are identical database engines. You can connect to whatever database and do your transaction, and it will be replicated and already highly available. And here's a sneak preview of the benchmark results that's coming in later in this presentation. It should show you that it really scales pretty well. The load that we are running here is Sysbench OLTP mode load, and this test was run on Amazon EC2 using large instances. And the red line tells you what the native MySQL distribution. This is MySQL file 133. You can get something like 480 transactions per second. Running Galera cluster, one node goes to the 400, so you're little less than native MySQL. But already with two nodes you get above MySQL performance, and then from that on it scales quite linearly up to 4 nodes. And you're getting more than 2 times performance for nodes. So this is something that I have not seen in the database replication world earlier. The content for this show is shortly here. Many slides I might need to jump over some of those, but let's see where we need to focus it. First, something about Codership, who we are, what we are doing. Then the Galera, how the architecture works, advanced features of that. There are little limitations. Then I saw benchmark results from Sysbench, DBMS, then one generic SQL benchmark, and finally the Drupal benchmark. So we have implemented the Drupal cluster using Galera Replication to replicate MySQL database underneath the Drupal instances. And finally a roadmap and the scales of the code. Okay, let's get back to the beginning. I'm Seppo Jaakkola and CEO of Codership. My team is, we are actually 3 persons in the kernel of the Codership. Alexei Yurchenko, Russian, Teemu Ollak, also Finnish as I am, and then a few hangaround guys backing us up. We are Finnish-Russian community and we work from Finland. As a team, we have worked together in database replication like 6-7 years already. And each person has done quite a lot of related engineering work earlier, distributed systems. I have been in a firewall clustering product implementing a Linux-based cluster firewall and also a in-memory database system. Listening to the previous presentation gave a flashback to me times. Those times it's pretty challenging effort that those guys are doing. But generally, our team, 2 years ago, in October 2007, we decided that we put up a company on our own just to have fun and work on the code in the way that we like. And we started implementing the Galera Replication system at that time, and also to earn our living we do consulting, and we divide our work so that half of our time we work for living and the second half is for fun. Okay, let's look at the foundation of Galera Replication. So the reason why it's so good is a replication method. It's a certification-based replication model. There's quite a lot of research around this topic. We mostly follow Fernando Pedon's ideas. He's our godfather in this project. There are many others, some other implementations. Maybe you've heard about Postgres R, which is pretty good in the same scene, and also Corda project that might also deal with MySQL. So yes, they have a MySQL extension. So Corda is related, Postgres R is related. And what certification-based replication model gives us is the possibility to create multi-master synchronous replication that gives us high availability out of the box. We have no middleware, or we don't need to use middleware. It's possible to use it, but there's no real need. Connections go directly to the database and uninterrupted, and they see the database as an empty database. There's not many differences. The logging is row level, and it makes it scale, makes the right scale. We can scale even with 100% write load. This may sound a little amazing, but that's how it goes. Some further details. The implementation is a software library, C, C++. We also use Boost quite a lot. It's generic, so we have an interface to link with practically any database engine. We just need to have some hooks and interface implementation to the engine itself. Our first proof of concept implementation was MySQL InnoDB, but we are really looking out so that we have somebody, if, for example, from Postgres community here, so chance for you to get in this project. Then a little more details about this. So this is quite similar picture as the first page, but it shows you that we have a Galera replication layer, then we have at the moment, so that we only have a MySQL implementation, we have MySQL, and then we have a implementation layer which we call right-set replication. We implemented that. It's a change in MySQL code. It's available in Launchpad, and it implements the interface that this certification-based replication method requires. Okay. Then it's true multi-master. You can really update same tables. You can have conflicts. Okay. If you at the same time update with exactly the same row, one of the transactions will lose, and it will be aborted because of that. You will get a deadlock error code. It depends on your workload if you have a lot of these kind of situations or not. It's synchronous, so when you commit one transaction, before this commit returns, the replication layer takes the write set to the cluster, and well, it does not necessarily apply it yet, but it's safe in each of the nodes. It might have been applied already, but we know that we have it in safe place in all of the nodes. So if you are able to commit, you are already highly available. Then, yes, there's scientific content warning, burning, something about the certification-based replication. I think this on a high level. The Pedon's dissertation paper was like 200 pages is a short abstract of it. But the idea is that we let the transaction proceed until the commit time. And before we commit, we collect a write set which contains all the changes during this transaction and also identification of the rows that have been modified. This transaction is then broadcasted to the cluster so that each node will get it. And we run a certification test that will check that has this transaction modified something that has been at the same time been modified in some other cluster node. Certification test will tell you that can you commit or not. Well, in the last line, it says snapshot isolation. This is basically the requirement of the transaction isolation level. It's not a strict requirement. It's very good if a storage engine can support that. InnoDB does not, and we needed to implement something to cover up that hole in the InnoDB design. Here's a picture, maybe there's more than those words. Here are two nodes. We have a transaction running to the leftmost node. During the transaction processing time, we collect write set information. For each query, we collect a little bit information. The yellow spots there are our integration tools to the Galera library. So we need to do something when we see situations in the query processing state. At the commit time, we extract the write set, white box over here, and pass it to the replication layer. Replication does a protocol called total order broadcast, which will send this out to the group of the members, all the nodes in the cluster, and also assign a sequence number for this write set. We know that this transaction is committing at this point of time, and all write sets that are currently in the replication, they form a queue, we call it slave queue for each of the nodes. And you can see that if there's a lot of write activity, at the time of commit, you have several write sets queuing up for applying in this node. And certification test is only about checking that are the modified here something that has been modified. And if there's a certification test is run on every node, so also in the node that is coming, it will run exactly the same certification test. And the test is deterministic. You only need to see the write sets, and then you can tell that it's good or bad. If the verdict is bad, so you cannot commit, then you run to rollback. If it's good, then you commit. In the applying side, the write set goes to the certification. We run the same test, and if it fails, it just drops this write set, so nothing happens over here. But if it's good, then we start it applying, which will make the changes which are described in the write set. So, okay, this was the Verona's dissertation. There's something more. Our implementation is generic, so we have a library, and we connect with the database engine. We have a layer, write set replication hooks, so we need to implement something, we need to call the library, and we also need to provide some callback functionality. The Galera library itself, it contains a number of layers. We have a provider for the wsrep, we have certification, functionality, replication services, groups, communication system framework, and it's a pluggable framework where you can plug in different group communication implementations. We started with spread. Spread is red because we did not implement it, but we implemented DBMS, synchronic implementation. This is available, and spread is available at the moment, and checkpoint is the next generation. Group communication that is coming should have come already. I hope it's ready on September. It's closed for our next release. But anyway, with ESPS and Rep, they are okay to use at the moment. They have some issues. ESPS has a single point of failure, which is not very nice. It's possible to overcome that, but we have to do it here, trusting in the G-code generation. The API itself. So we have defined an API between the database engine and the replication system. We have a project for it in Launchpad which just shows that this is the API. These are the function calls that must be provided in the database side, and also the callbacks that must be able to call from the engine. So it's a two-way call system. And it has functionality for the actual write-set replication, but also for applying of DDL commands. It goes a bit differently. DDL processing is not same as transaction processing. It's not part of certification-based replication. It's in addition to that. And then the integration. So we defined this API. MySQL did not implement it. We asked for it, but they did not. Okay, I understand why. It's a big task. We started to implement that in October 2007. Early this year, January, we were able to publish our first release for public testing. So it took like a year and a half to really implement it so that it's testable. And this implementation just implements the hooks, the handles and the calls in the correct places. The most challenging part is what we needed to implement for InnoDB is the concept of privatized transactions. It was not there. We asked Heikki also to implement that part. But I understand he wouldn't think that this is a high priority job for him. And there's a project in Launchpad, so you can see the code. There's like rough average 4,000 lines of modified code inside InnoDB and MySQL code base. I removed all the comments to make the patch smaller, but we are still in 4,000. It's a bit too thick footprint, I think. There are a couple of issues. I think we can spend it a bit. I have talked about it. Yeah.
So do you maintain just the patches themselves, or are you having a separate branch that includes the entire MySQL code base?
It's a separate branch. Yeah.
Okay. So you basically build binaries which include your patches and provide them for others.
Yes. It's on. We are branching from MySQL Server 5.1.
Okay.
All the code is there. Then the write-set. This is maybe the key concept. It's all about write-set delivery, box delivery. Whatever is contained in the write-set is good for replication. So it contains all the information that is needed for certifying, for running the certification test, and for applying of transactions. The information for applying, it can be specified in several levels of, we call it replication level. Maybe this term is not very good, but it just tells you the query processing level. So the first and uppermost is SQL statement. You can just put the SQL that you had that came to the server, and that's good for applying. It's not very good, but it's a good start. Then we define 4 other layers. We have implemented the SQL statement level and row-based replication event layers. It could be a less structure, so it's the abstract syntax tree serialized. So in theory it's a good idea, but looking at the MySQL less structure, you don't want to do it. It's a bit complicated. It's not serializable. But we have a SQL statement level and a row-based event support. We need to implement rows, at least for Postgres, and we could implement column values directly. If you have a long tuple length blobs in a tuple, for example, you might just want to replicate the real delta to shrink the right set. Right set looks like this. It has the applying info, but it has also some header information. Sequence number comes from the group communication. The total order broadcast tells you that what is your sequence order. This tells that where this transaction belongs to. Then we have a reference to the transaction that has been committed at the time when we are committing. And the difference between these two sequence numbers tells you the domain of kind of hostile rights that might have modified, might be conflicting with me. Then we have key information. All the rows, we extract the exact key information and put it here, and also the applying information. So at the moment, we can, from MySQL, we can put the SQL statement or the buffer of the row hardware events. Something more about right set. Okay, we don't want to keep them too long. We flush them as soon as we don't need them anymore, but we need to collect the key information. We built our own certification index just to speed up the certification test. This is just for convenience for us. It's not actually needed. But those right sets, they can be set for future needs. We have a MySQL variable wsrep vs persistency, and if you set it on, then you will get all your right sets on this in binary format. I use it for debugging, but we are going to use it later on to implement a field support incremental state transfer when we need to send delta of the modifications coming to this node to some other node who can do the catch based on that information. Okay, so here's a short recap what should be understood. So it's a true multi-master, really synchronous. Yeah, the replication method is certification based, that makes it fast, and we are generic, whatever database is good to deal with, and we have a API that just defines that who can use Galera Replication. Then there's a list of some advanced features and well, maybe not features, but also some something that describes the behavior of the system, like optimistic concurrency control. It's not something that we added there, but it's there inherently. But we have implemented flow control, auto-increment management, parallel applying. Okay, we have it, we don't use it, and some other features as well. Let's go through this list. First thing to understand about certification-based replication is that it's optimistic in nature. Each transaction is committing and hoping that, or believing that I can eventually commit, but that might not be the case. At the commit time, we need to run the certification test, and there can be a conflict. And if there's a conflict, the victim must die. And it means that actually if your client is saying commit, usually you would assume it to succeed, but in Galera cluster you can get deadlock error at that point. That's not very transparent, but that's something that you cannot just avoid. Because it's optimistic. The database engine InnoDB, for example, it's a pessimistic concurrency control system, but the Galera cluster on top of the InnoDBs behave optimistically.
So does the application get any kind of feedback if the transaction actually went through or not?
Yes, if it went through, you get success return, but if it fails, you get error deadlock.
Okay.
It's possible that there are applications which are not checking the error code of commit, expecting that if I was successful so far, this must work out. But okay, a good application, a robust application, and certificate operation but there are, for example, Drupal. It doesn't check. We needed to make a fix for that, specific. New variable for MySQL implementation to be able to run Drupal cluster. So what comes out of the optimistic nature, it means that hotspots are bad, they can be really bad. For example, the DBT2 is a bad benchmark. There's a lot of conflict, there's a small set of tables, just one row that is changed. It's bad. But we can still scale with DBT2, so it's not too bad. Long-lasting transactions, they are vulnerable because they need long, they keep their logs long, and the probability that somebody else is modifying this change set grows to run longer. Rollbacks, they are bad for performance. Committing is fast, rolling back is slow in database engine. In InnoDB and most of the databases. But the good news about this is that you need to roll back only in one node, always. So if you have a large cluster, roll back here, but you might have 7 other nodes who don't roll back. And if you have a very problematic SQL profile, it's possible to do some adjusting and, for example, to limit the number of nodes where you actually want, right? So you can work out of this cluster-wide deadlock situation by directing your load, application load, adjusting it in a nice way. Load control is something that we just needed to implement, something we did not emphasize beforehand. Galera cluster is synchronous, and it means that each node, they should and they actually must operate in the same frequency. If there's nobody controlling how they operate, it will quite soon happen that 1 or 2 nodes start to dominate the activity. They turn into real masters and everybody else is just a slave role. Slaves get deadlocked all the time. This happens in say 5 seconds if you have a really high load on a cluster. And to deal with this, we needed to implement flow control. We have a limit for the slave queue length, and nobody can push more than fits in the slave queue, they must take. And it makes it look pretty nice. Auto increments, it's good that we have these variables. I don't know who picked up the names for auto increment, increment, and so on, and auto increment blocks. But using these variables, we can make sure that inserts in each node, they get unique IDs for all the rows. So you can insert it and you can be sure that it's not conflicting with anybody else. So we are using these MySQL variables and we have automatic management for these variables as well. So the cluster knows the size of the cluster, how many nodes there are, and it can adjust these variables. You don't need to do it. When you start Galera, you will get your variables adjusted. And we have a variable for telling me if you want this feature or not, wsrep auto in control. It's a good idea to keep it always on, that way you know that, okay, you can freely insert and no conflicts will happen. Okay, and the way that the Galera cluster works is that we know the changes in the group membership, and whenever we have a change, these variables are recalculated. Having this auto increment control, you can get the best possible insert performance. This is not a feature, this is a behavior of the cluster. It turns out that these brackets, they contain just the row IDs of rows changed in this transaction. It's a minimal domain of change definition. So you know that these rows have been changed. But when you apply this transaction, the database engine might need some extra locking. For example, InnoDB needs gap locks. But this is a logical problem. Some other engine might need something else, whatever resources. And it means that just looking at the right set, you cannot tell in advance that can I really apply these two right sets at the same time or not. Information contained in the right set does not tell you that, and you must prepare yourself for the possibility of applying buckets. Okay. That's a feature that we did something to work around that issue. All right. Yes, this is a to-do list, but we were thinking about that. Can you really make the instant even faster? And it's possible because we know if we are using the auto increment control, we don't know that there will be no conflicts in that with anybody. And then if you know that the transaction is only inserting and is getting implicit auto increment values, so they come from the auto increment counter, then we know that this transaction possibly can conflict, and we could avoid all this application. So to skip it. This is not to-do list, so but it's coming, I guess, quite soon. It's simple to implement. Retrying is something that this is the thing that we needed to implement for Drupal, which is quite picky about the way that the MySQL database engine works. Drupal can, for example, delete all the authority information so that nobody can log in Drupal anymore. It is an issue at this level. And what we did is that if we have an auto-commit transaction and it enters in a cluster-wide deadlock and it's going to be aborted, we don't tell it to the client, but we immediately rerun it because it's auto-increment and it's a DBMS. It's safe to rerun. Better luck next time. We have a variable for it. Here's a retry auto-commit, and that's what we need to do when testing Drupal. Parallel applying, it's possible, we have implemented it. There's an option for it, VS slaves, you can put it to whatever value. Well, okay, there's a hard code limit 4 at the moment, if I remember correctly. And if you set up many appliers, they will run in parallel until commit time. So still the commit point is serialized. Committing happens. That could be relaxed, but it's quite risky, at least at the point when your node is crashing and you don't necessarily know that if you're having holes in your execution so far. Okay. It could be relaxed, but it's not relaxed at the moment. I had high hopes about this when I implemented it, but then when I started to test, there's absolutely no gaming performance. I tested with 2 nodes, having 2 appliers, exactly the same, because no change. And then I monitored that what's happening. Are they really applying in parallel? Yes, sometimes you can see, and quite often there are 2 appliers, and the applying takes, well, some time, and then they commit serially. But the result is the same. And why? My conclusion is we are really even applying it just so fast compared to anything else. The master who's sending the query went through all the SQL statement processing from parsing up to generating this RVR element. And then when we apply it, it's fast. We have seen in our benchmarking that even if we have 100% writes, it's just writing to the database, it still can scale. So applying of RBI events is faster than just processing the SQL queries. So if one node gets half of the writes to be processed through SQL processing and half coming through RBI, the part of the RBI event leaves you some part of CPU headroom to do something extra, to get more connections to that node. That's how it works. And then something that really kind of adds smoke to my desktop with this is the flow control. Which I just couldn't turn off. Flow control can limit the number of connections, queries coming to the replication, and that can limit the parallelism that I would like to see in this applied case. So perhaps I need to rerun this test different setups, but still, because I'm able to scale with 100% rights, I don't believe that anything can come out of it. And we have a bug in the implementation. We assume with block granularity issue. I have not solved it. I did not solve it because I'm the first one to find out that what is the gain. Okay, when I see that there's no gain, I'm not solving this issue. But I can test with a well-defined benchmark. I can really run it to the completion and see how the system works. There was a discussion about this in Drupal mailing list. But I guess we are talking from different planets here. People don't seem to understand my message over here. But I think that I'm going to rerun this with a better hardware and better resources. Alright, connectivity. So Galera is truly multi-master. You can connect to whatever node, and it's better to connect directly to each node. You can have a connection pooling on the client side if you wish. So the DBMS driver can do that for you. The fastest performance always is direct connection. But you can use some middleware. You can have TCP level load balancers. They are really fine with Galera. We have used PEN, and we have our own Galera load balancer GLB load balancer, which is pretty fast.
So the client still is a plain old MySQL client application talking to MySQL client server protocol.
Yes.
Okay.
There's no change on
I
that.
would either have to change my application to be able to talk to multiple MySQL servers, or I would use one of the load balancers you mentioned below to distribute the load.
Yes.
Transparently to the
Yes, if you have a JDBC application, you could get a JDBC driver, which does this connection pooling for you. GLB is good. You actually, and the one alternative is proxy, for example, MySQL proxy. We have a picture here about the alternatives. If you don't want to put the addresses of the nodes in your application or in your connection pool, then with TCP level, load balancer, whatever, or use MySQL proxy. Listening to the MySQL proxy presentation, it gave me some ideas. There's really some good use cases in MySQL proxy. Alright, database state transfer. This is something that is needed when a node joins the cluster. We have an active cluster running, there's a load on the cluster, and we have one more node wishing to join. Then we need to get a state of the database in a given time. The task is to, we must pick up a donor, some node from the active cluster, which must prepare a snapshot of the state in a well-known position of the replication stream. So we have a sequence number, and we have something telling that this is the database state, and the joiner must then just load this state and then know that from this sequence number on, I must start applying right. So this is the task in high level. We are currently in release 0.6, and what we are putting out is 0.7. It's coming out anytime now. There will be an implementation which is based on MySQL dump. So we are just running MySQL dump on this donor node, and then we load it to the joiner. What's coming next? We can directly tell that MySQL dump is not the final word in this implementation. There must be a faster way to do it. Extra backup is pretty good. LVM use maybe. Extra backup than InnoDB hot backup. They look like the same product to me. But this is, we need a license to deal with the InnoDB hot backup. That's why we start to implement with the extra backup. That's our reality for us. Yes, what needs to be done, we have a joiner and donor. Donor takes the backup and assigns a sequence number, and we have the replication sends it back. And
so the joiner gets preloaded with the previous state of the database. As it's being loaded in bulk, then it joins the cluster, and then it gets all the updates that have happened since.
Sees that sequence number. Yeah.
Okay. So could I just add a new joiner and let it start by sequence number 0, or would that take too long? Or are the sequence numbers not around forever?
Well, yes, we are. Well, we can maintain the bright sets persistently. So we have this variable that the node will collect the long tail of bright sets.
Yeah.
And that can be used as well. But well,
I was just wondering what is more convenient. If I first have to prepare a backup, install it, bring up the node, and then it still has to replicate sequences that it hasn't received yet. Why not start from scratch and just set up an empty node and let it fill up until it's in sync with the others?
Yeah, this is an optimization problem, because you don't know that what is the size of the database. If you have a terabytes, you don't want to dump too often.
Right.
If you have a very large database and write rate is low, then so you must optimize and find out a good solution for it. This is the, I don't understand this. I wanted that. When this was implemented, this snapshot state transfer in July, I was in holiday in Spain. Guys did the implementation, and I wanted to give you a design document, and this is it. But it just tells you something, and also tells something to me is that we need to do a lot of synchronizing before we are able to really run the dump. We need to find out the donor loop communication can tell it, and find out the correct spot in the donor side where to store, and when to get the dump, and when to restart the activity on that node. During this dump time, the donor node is passive, so it doesn't commit anything, and that's bad.
But it accumulates the write sets, and you can apply the write sets after the dump?
Yes, the write sets, they are buffered, and
so the cluster does not stop.
Yes, there are more nodes, hopefully. Hopefully this list will continue through that wall. And there are more active nodes who are processing, and this node is just passive for the time of dumping. But anyway, you don't want to spend too much time here. LVM is good solution, because this time is like 2 seconds.
How is the donor being selected? What criteria are being used?
Yes, I would like to know that also. I was in Spain, I was having a good time. But the group knows something about the state of each of the members. So it can see the length of slave queue, for example. Yeah.
Clients that are unlucky to have connected to the donor will have to keep.
Yes, if you have.
So you should have clients that only connect for a short time, or separate?
Yeah, it depends on the client implementation. If you have a TCP load balancer or GLB, it can direct you to the new node. It will see that there's no response from here for time being. MySQL proxy could do this. One more use case for using MySQL proxy. You could tell the proxy that this guy is going down for a while. Okay, and you are routed correctly. Hopefully. Also, a very clever application can do all this. It depends on the use case. Process automation systems, it's one possible use case for us. They have very clever applications. They can really find a way the correct node to talk to. Okay, let's get out of this. Limitations now, something we have identified. Another twist in my transparency. The first and foremost is the deadlock during commit time. So this can happen. We can avoid it for auto commits transactions at the moment. Perhaps not for multi-statement. I guess it's not possible because multi-statements can have selects, and they, based on this return values of these selects, some DML action happens, so we can't do it if it's consistent anymore at later time. But for auto commits, we can kind of recover from that. We need to implicitly implement snapshot isolation, given that you think that your schedule was repeatable read, what you receive is snapshot isolation. That's something to think about. I think that most MySQL users, they just don't know what it is, and they are happy with it. Most use just auto-commit transactions and tables. On SQL level, we have some limitations. This list can be longer. I have not identified all the possible corner cases, but out of the box, I know that the logging sessions are not supported. Load data has some issues, of course, log functions as well. Okay, I have some slides about each of these. So log tables, my immediate answer is no. I can relax it a bit, say no, but perhaps. Anyway, it's going to be quite complicated. I hope that nobody wants to use those. In principle, what needs to be provided is a long-term session for each node. We would perhaps need to have a session cache for long-running logging sessions. Let's not talk about that. Load data in file. If it runs a server mode so that you load from the local server, okay, that can be implemented. But is it very practical? You would need to know that whatever you are loading is identical. In high level, what is a cluster? It's actually just a consistency provider. Can you provide consistency if you depend on just some text file? How did it go there? What does it contain? There's no guarantee. Yes?
Why can't you just replicate the rows you load from the file and not the statement?
Well, it works with load data local, in my log. Actually, you get the stream from the client. We can do it. We don't implement it. We have not implemented it. It's possible to implement, but I think that what you are usually going to get is you're going to get a stream of incoming bits and bytes, and you would like to split it, to fragment it. Maybe I have a feeling that we are not happy to build one huge write set out of that stream. We don't know when it's going to end. The client is just sending something, we are accumulating a write set. Okay, but this is not a to-do list. It's possible, and this is also something that we need to implement. This is a feature. At least this load data local is something that quite often I see it being used. MySQL support, this has been asked already. We have identified at least one way to do it. If you really need to have MySQL, you can quite easily support it by just routing it to one node. And then we can replicate all that. MySQL is not transactional, we don't have this rollback feature. Whatever you have updated, you cannot take it out. That's the issue with MySQL. But if you know that all the writes go to one node, you can still replicate the changes to RDL. And that would be good. And we can let Galera decide that where the MySQL master is, and for example, do the routing of the connection. If you want to write to wrong node, we can route it to the correct destination, or then we can just reject the wrong address. I have a feeling that we need to implement this. I don't too much like that, but it seems to me that it's necessary. Something more about the to-do list, large write set. Something that can happen, so that you can have transactions. Our benchmarks don't deal with very big write sets at the moment, and this is something where we need to do quite a lot of testing. But it's possible that you want to modify many tables, many rows, and your write set grows, and that will cause problems. And it makes you want to limit the size of the write set. Then there are two possibilities: to escalate log key, so that way you can take the key definition part inner, less keys, and escalate the page level, whatever, more higher level, table level, database level, server level. Or then you could escalate to SQL statements as well, so you don't necessarily want to replicate anything all through RDRs, but just decide, okay, this is too big chunk, let's put just this statement. But there are issues in that. Not all statement replication is steady, so we need to do some optimizing there. Also, long-running transactions, they are vulnerable. The longer you run, the more probability of conflict possibilities. All right, finally benchmark. How much time do we use?
Roughly 10 minutes.
Okay. All right. Maybe 10 slides, so still go. Benchmarking, we have done quite a lot. We did during the winter time. We got our first releases out in January, then we benchmarked quite a lot. But now during summertime, not much benchmarking anymore. We do a lot of testing, so maybe half of our time is testing, but running a benchmark and publishing something, we need to take a serious consideration for that type of tool. We work, and that's why we have not run anything. But I have a feeling that we are going to have a benchmark round in this, after this next release, 0.7. We have tested with physical hardware, which is not very reliable hardware. We just don't have resources that much. That's why we went to Amazon EC2, and that's pretty good testing, but it has issues as well. It lacks, for example, Unity multicast. We must through communication can, as layers, transportation layer, we can also do TCP level. That was we use most. Currently we have tested only up to 5 cluster node size. This is something we need to continue to find out the real limits. Because of this optimistic behavior, I would expect that the scalability curve will start to go horizontally and also turn downwards, because the more conflicts, nodes you add, the probability of conflicts will go higher, and we will end up in a situation that adding one more node in this soup will make your performance worse, depending on the profile. And we need to see that, identify those loads and where is the limit for the best possible performance. This is also something that MySQL proxy would do. It would monitor the system performance. See, if I write to 3 nodes, I get this much performance. Let's try 4 nodes. Okay, get first back to 3. This is positive. Okay. This is the Sysbench, the same Sysbench with the real figures. Well, now the scaling is different. Here we are comparing against, I think this came from Alex, these drawings, he always compares against the native MySQL. So if you are at level 1, it tells you the performance of the native MySQL, and then we are comparing against how much faster are we the native MySQL. This is the same curve. The exact figures is there. So you can see the transaction per second native MySQL 451, and in 4 cluster you will go over 1000, so 2.3 times more performance. DBT2, this is the problematic load. MySQL level is here. 1 node, 2 nodes. Here we go directly above MySQL. In this test, which I did not do, Alex Martin did, we made a new option for our Galera node where we can avoid writing the winlog file itself, so we don't accumulate any disk operation. We've got a little bit more optimized with that method. And what you usually are looking in DBT2 performance is the number of new transactions per minute. You can see the figures down there. Then we have a rollback rate percentage, so it goes higher. 4 nodes you have already 5%. So the red curve is about what happens with the rollbacks. And you can see that even a small increase in the rollback rate will turn down the performance curve quite soon. This 60 warehouse case. So all those transactions, they're quite long transactions, they are competing of 60 data items. It is a hotspot. But still it scales a bit, maybe 3 nodes. It's not safe to add 4 in this scenario. Drupal was our test with the Drupal conference. We wanted to show that how can you scale. Drupal does not have a scalability solution. So if we have an Apache cluster, Drupal PHP running there, and MySQL, this is Drupal 6 version. Drupal 5 has locking sessions. That's why I skipped it. And we have each node has a stack of Drupal, MySQL, and Galera. This is something that you don't actually in real life want. You don't want to implement it like this. And the reason is that only 10% of the CPU goes for MySQL. Apache Drupal is so CPU hungry. It's not a very good balance for resources. We need this just for proof of concept to see that Drupal has a quite wide range of SQL coming. We wanted to see that we will really implement storage.
It confuses me. Do you have 3 separate Drupal instances? Or 1 Drupal instance that talks to 3 MySQL servers?
This is one server. and you have Drupal running and MySQL running in the same node. And then we have a GLT, load balancer, and client connections come here, and you get directed to just one of those nodes. Our test is a jmeter test. Okay, let's see scale. It's better here. We have a HTTP test with jmeter, which has 3 different groups of connections. It has posters who write more pages, commenters who read the pages and give credit to the authors, browsers who just keep on reading. And we created these in a proportion of 4, 12, 24. In total, it adds quite a lot of right in the system.
So the load balancer that you have in front of it distributes HTTP?
Yeah.
Okay.
This kind of HTTP goes to whatever Drupal. And there are some issues. Are there Drupal persons here?
No, all next door.
Yeah, okay, these are for them. But the results, this is skyrocketing. This is good to show to Drupal guys. But for my database guys, this is there's practically nothing because yes, it's a Drupal. We have 10% MySQL load and that's it. But the good news for Drupalist is that you could do this installation and really scale, put them hundreds of nodes if you can afford that. The real way to do it is of course like this, that you build one 10 Drupals and one MySQL server in a cluster. You have a kernel of synchronous kernel, then you have a Drupal and all the caching that you need for the client side. And this makes you a pretty good site. Oh, really? Maybe here is the right benchmark with 100% right rate. You can see it grows quite a lot. Hardware applying is pretty fast. Absolute values. This is a rotten hardware. HP volume updates 4,000%. Right. Project. So okay, maybe this is still something that is we started releasing January. We are in release 0.62. And we have plans for new releases. 0.7 is the next. It's fully open source. So far we have not given out the code for 0.6 Galera library, but it's coming in a 0.7. The idea was that the 0.7 would have been out today or a week ago. We would have it there, but it's not. We have issues with the code communication. Next week maybe. The next milestones, we have some new features up to the year end, maybe 0.7, 0.8. The extra backup. And maybe something for other database engines. So we are reaching out. We want to spread this news. We are integrating with MariaDB. They are open for contributions. We are looking closely at result. We want to work in Postgres. Markus Wanner made a nice Postgres R implementation. It's a good basis. It's quite close to the wsrep implementation already. But we don't have time for this, so anybody who can take care of that, there's an open road. Okay, that's about it. Any more questions, comments?
Interesting stuff.
Yes.
Your application is synchronous.
Yes.
It means that until walk set isn't implemented on all slaves, you cannot commit transaction in master server, right?
Yes, we don't. Actually, we don't commit it in every node, every other node, but we just accept the rights. We have certified the right set. Possibly it's not yet committed there, but it's saved in every node. So we could also require that it needs to commit, but that takes quite a lot of performance. We are happy with it that we have the right set in every node. Every node has acknowledged that, okay, I have the right set and you are good to commit. Okay, anything more? Thank you. Okay.
All right, coming up next is our panel discussion. We start at 4:30.